Hi everyone, welcome back. In this lecture, let us take a look into the introduction to JUnit. Well, what is JUnit? Well, JUnit is a testing framework for Java. Well, JUnit framework is a de facto standard for writing unit test cases in Java. One of the key features of JUnit framework is that it allows you to create unit test cases that can be run over and over again with consistent result. Next, JUnit helps to verify that individual units of code works as expected. Well, the main goal of JUnit is to help you verify that small individual parts of your code such as methods or functions perform correctly. By writing JUnit tests, you can check whether your code behaves as intended even as you make changes and add new features to your code. Alright, so JUnit is one of the well-known testing framework to write the unit test cases in Java. Next, let us see how JUnit works. Well, JUnit framework provides a lot of annotations to write the unit test cases in Java. Well, in order to write the unit test case using JUnit framework, we first write the method and we annotate that method with @test_annotation. Next, JUnit framework provides a lot of assertions that we use to check if the results are as expected. So JUnit framework provides a lot of assertions that we can use to check whether the expected output or the result is matches to the actual output or a result. Next, JUnit platform has a test runners. So test runners execute the unit test and report the results. Next, JUnit can be integrated with IDEs and build tools for easy execution. Well, JUnit nowadays has an integration with the popular IDEs like IntelliJ IDEA, Eclipse, VS Code, okay? And JUnit perfectly works with build tools like Maven or Gradle. So basically JUnit has a good integration with IDEs as well as the build tools. Next, let us quickly summarize how JUnit works. Well, here is a Java code that we want to test is known as class under test. Next, we want to test the Java code. For that, we write a unit test using JUnit framework. So JUnit framework provides a lot of annotations to write the unit test cases. Next, JUnit framework provides test runners. So these test runners will basically execute the unit test cases and report the result. Next, let us take a look into key features of JUnit. Well, JUnit framework provides a lot of annotations to make test management easy. For example, JUnit framework provides @test, @before, @after annotations to manage the execution of your test. These annotations help you organize your test code and specify how and when certain methods should be run. Assertions are used to check the expected results. Well, JUnit framework provides a lot of assertions that we can use to check whether the actual output matches the expected output. The JUnit framework provides a variety of assertions like assertEquals, assertTrue, assertNotNull, assertNull. Alright. Next, test runners execute your test and report the results. Well, JUnit includes test runners that are responsible for executing your test cases and reporting the result. When you run the test suite that contains a list of test cases, the test runner handles the execution of each test case, captures the result, and provides a summary of which test passed or failed. Next, JUnit supports integration with build tools like Maven or Gradle. Well, JUnit easily integrates with the popular build tools like Maven or Gradle, which are commonly used in Java projects. This integration allows you to automatically run your test cases as a part of build process, ensuring that your code is always tested and verified before it is deployed. Alright, so this is a quick introduction to JUnit framework. In next lecture, we'll take a look into JUnit framework architecture. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. Before writing the unit test cases using JUnit framework, let us understand some of the basic concepts and terminologies related to JUnit framework. And these basic concepts and terminologies we will frequently use while writing the unit test cases. The class or system we want to test is known as system under test or a class under test. The method or function we want to test is known as method under test. The test class in JUnit is a regular class that contains one or more test methods. These test methods are annotated with @test annotation and contains the logic to test a specific piece of code. Well, test class in JUnit is nothing but a regular Java class. It contains methods which are annotated with @test annotation. Next, a test method is a method within a test class that is annotated with @test annotation. This method contains assertions that check the expected outcomes of the code being tested. Well, a test method is essentially a unit test. Well, in order to write the unit test, we create a test method. So basically we create a method and we annotate that method with @test annotation. And this method is called test method. Next, assertions. Well, assertions are used to check whether the code under test behaves as expected. JUnit provides several assertion methods such as assertEquals, assertTrue, assertFalse, and assertThrows. So apart from these assertion methods, there are a lot of other assertion methods as well. Next, the test runner is responsible for executing the test methods in a test class and reporting the result. In JUnit, the test runner is typically provided by IDE or build tool such as Eclipse, IntelliJ, Maven, or Gradle. Well, test runner is responsible for executing the test methods in a test class and reporting the results. And most of the popular IDEs like Eclipse, IntelliJ have inbuilt test runner, and also the build tools like Maven or Gradle also has a test runners to run the test methods. Now let us understand all these basic concepts with an example so that you can remember easily. So here we have a calculator class. Within that we have add method. So now we want to test this calculator class, right? That's why it is called a class under test. Next, within a calculator class we have add method. Now we want to test this add method, so it is called a method under test. Next, here we have a calculator test class. It is basically called a test class. So test class is a regular Java class. It contains test methods which are annotated with @test annotation. Next, here is a test method. Test method is a method which is annotated with @test annotation, and within a test method we write a logic to unit test the method under test, and we'll also add assertions to check the expected output with the actual output. Next, assertions. Assertions are the statements that we use to check whether the expected output matches the actual output. For example, here you can see assertEquals. AssertEquals is the assertion that checks the expected output matches to the actual output. If expected output matches actual output, then this test will pass. Otherwise, it will fail. Next, test runner. Well, test runner is responsible to execute the test methods within a test class and report the results. And most of the popular IDEs like IntelliJ, Eclipse, VS Code. So these IDEs has inbuilt support for executing JUnit test cases. And this is the IntelliJ IDEA. It has a inbuilt test runner. So we can use test runner of this IntelliJ IDEA to run the test method. For example, from here I can run this test method and you can see the result. So test runner basically responsible to execute the test methods within a test class and report the results like this. Alright, so these are the important terms or concepts that we frequently use while writing the unit tests. Alright, so class under test, method under test, test class, test method, assertions, and test runner. Alright, I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll quickly set up the environment for JUnit. Well, we'll create a Maven project in IntelliJ IDEA and we'll use Java 21, which is the latest version of Java as of now. And then we'll add all the required JUnit Maven dependency to the Maven project. Okay, so basically we'll do the setup in this lecture, and in next lecture onwards we'll start writing the JUnit test cases. So the first step is create a Maven project in IntelliJ IDEA. Well, let us open the IntelliJ IDEA in our IDE. So here I have opened the IntelliJ IDEA, and go ahead and click on this new project to create the project. And next here, let us give the project name as JUnit tutorial, and here choose the location where you want to keep the project. So in my case, I choose desktop. Next here, build system. So make sure to choose the Maven build system here. Next, let us configure Java JDK to this project. So here we are going to use JDK 21. So here I have already downloaded the OpenJDK 21. If you don't see this OpenJDK 21 here, you can go ahead and click on this download JDK and you can choose the latest version and you can download it. Okay, so just go ahead and choose OpenJDK 21. So you can use either Oracle provided JDK or OpenJDK. Okay, perfect. Next here, go to advanced setting and here let's give group ID net.javaguides. So here I have given group ID net.javaguides, but you can give any group ID that you want. Next, go ahead and click on create button, and there we go. A JUnit tutorial project is successfully created. Next, if you can see here the packaging structure or project structure. So this is the Maven provided standard project structure. So this is a main class, and here is a test package. Within a test package, we write all the JUnit test cases. Okay, next go to pom.xml file, and here you can see Java 21 is configured. Alright, now we have created a Maven project in IntelliJ IDEA and we have used Java 21. Next step is adding JUnit Maven dependencies. Let's head over to the Chrome browser and here just type JUnit 5 Maven, hit enter, and go ahead and click on this JUnit Jupyter engine link. Alright, and scroll down and here you can see the JUnit framework version 5.11.0. As of now, this is the latest version for me, but you may see different version in your case. Okay, so just go ahead and choose the latest version, whatever it is, and go ahead and click on this code here. So it says copied to clipboard, and go to IntelliJ IDEA and go to pom.xml file, and here create the dependency section. Just type dependencies, hit enter, and within a dependency section just paste this dependency. Next, go ahead and click on this load Maven changes icon over here. So this will basically download this Maven dependency from the internet. Alright, perfect. Now we have successfully added JUnit dependency to our Maven project. So as of now, this JUnit Jupyter engine dependency is enough for this tutorial. Alright, perfect. In next lecture, we will write our first JUnit test case. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to write our first JUnit test case. So first, we'll create a method that to be tested. It is called method under test. So basically, first we'll create a class under test, and within that we'll create a method under test. Next, we'll write a test method using @test annotation. So this is basically called unit test. Next, we'll use assertions to validate the method's output. So within a test method, we'll use assertions to validate the actual results with the expected results. Next, we'll run the test case and we'll see the results. Okay, so let us go and let us write the JUnit test step by step by using these steps. So first step is create a method to be tested. So go to the IntelliJ IDEA over here. In previous lecture, we have created a Maven project and we have added JUnit Jupyter engine dependency. Next, go to the project, go to the base package, right click on it, new, and then choose Java class. Let's give class name as calculator, hit enter. So this calculator class is a regular class and it is called class under test because this class we want to test, right? Next, within this calculator class, let's create a method public int. Let's give method name as add, and let us pass the method arguments int a comma int b. So this method basically is to addition of two numbers. Next here let us have return statement and then a plus b. Alright, so this is the simple add method. It will add given two numbers, and this method we want to test, so this method is called method under test. Okay, I hope the terminologies are clear to you. Next, let us see the next step. Next step is write a test method using add test annotation. So let's go back to our project again. Well, first we need to create a test class. Within that we will create a test methods, right? So in order to create a test class in IntelliJ IDEA, so just click on the regular class and right click on it, and then here click on this show context actions, and then here choose create test, and here testing library, let us keep JUnit 5 as it is. Class name, let us keep the default one, that is calculator test. So IntelliJ IDEA will give a default test class name which looks good. Next, here destination package, so let's keep this one net.javaguides. So this package will basically will create under this test package. Okay, next here you can see generate these annotations. Well, at before at after annotations are life cycle annotations, and as of now we don't want to use these annotations. Next, here is a member section, and within that you can see the method under test. So if we tick mark this method, then IntelliJ IDEA will automatically create a JUnit template for this method. So we'll create JUnit test case manually. So let us don't tick mark this one and go ahead and click on OK. Perfect. Next, if you go to test package, under that Java, and then net.javaguides, under that calculator test. So this is the test class. Within a test class, let us go and let's create a test method. Here just type public void, let's give method name as add test. Alright, so this is the regular method. Next, let us make this method as a test method by using add test annotation. So here let's annotate this method with add test annotation from org.junit.jupyter.api package. Well, this add test annotation marks this method as a unit test case so that the test runners will execute this unit test and report the result. So whenever you want to mark a method as a unit test case, then you can go ahead and annotate that method with add a test annotation. Alright, great. Next, within this test method, let us create an object of the class under test. So here calculator is a class under test. So let us create an object of calculator class. Calculator equal to new calculator. Next, let us have a calculator object. It has an add method and then pass 10, 20. So this add method returns the addition of 10 and 20, right? The result should be 30. So here int actual result. So the actual result is 30. Next, in order to verify the output of this method under test, we have to use assertions, right? So assertions are the statements that we use to check the actual result with the expected result. So here let us use one of the assert statement, that is assertEquals, to check the expected result with the actual result. So if you can notice here, there are overloaded assertEquals methods. We need to choose the appropriate one. So in our case, we need to choose the assertEquals method that takes integer parameters. Okay, so go ahead and choose this one. It takes integer parameters like int expected, int actual, and then pass the expected result, that is 30, and the actual result, that is actual result variable. Alright, notice here this assertEquals is a static method and this method checks the expected result with the actual result. If the expected result is not matches with the actual result, then this test will fail. If the expected result matches with the actual result, then this test should pass. Next, let us take a look on the next step. Next step is run the test and check the results. Let's go back to our project. In order to run this JUnit test case, we can go ahead and use this icon over here. Okay, if you want to run the complete test class, you can go ahead and use this icon. So in our case, we are going to execute this particular JUnit. So for that, let's go ahead and let's click on this icon and say run add test. Alright, and just scroll up, and here you can see test passed. Alright, so this is how we write the unit test case to test the method. So in our case, add is the method, and we have written another piece of code to unit test this add method. Alright, so unit test is nothing but a piece of code that tests another piece of code. Next, let us also see the negative scenario. So here the test is successfully passed because the expected result is matching with actual result. Next, let us say we are expecting 31, but the actual result is 30. In this case, the test should fail. For example, if I run this test case, here you can see the test failed, and if you can see the error message, expected 31 but it was 30. So this is how we write the unit test to test the logic of method under test. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into one of the important annotation in JUnit framework, that is at-test annotation. Well, at-test annotation is one of the fundamental annotation in a JUnit framework. At-test annotation marks a method as a test method. Well, whenever we want to make a method as a test method, then we can go ahead and annotate that method with at-test annotation. JUnit automatically runs all the methods annotated with at-test annotation. Well, basically, in order to create a JUnit test cases, what we'll do, we'll create a test class. Within that, we create a methods and we annotate those methods with at-test annotation. Next, when we run the test class, JUnit automatically run all the test methods which are annotated with at-test annotation. We don't have to manually run test methods one by one. When we run the test class, JUnit automatically run all the test methods within that test class. Okay, so we don't have to manually run test methods one by one. Next, use at-test annotation from org JUnit.jupyter.api package. Well, some of the students may confuse like from where at-test annotation should be imported. So make sure that you import at-test annotation from org JUnit Jupyter API package. Next, test method can be public, protected, or default visibility. In JUnit 5, test methods can be public, protected, or default visibility. Alright. Now let us go ahead and let's create an example and let us see at-test annotation in an action. So let us head over to IntelliJ IDEA, and here go to our project, go to this base package, right click on it, new, and then choose Java class. Let's give class name as Factorial. Within a Factorial class, let's create a method public int. Let's give method name as Factorial, and let's pass the method argument of type int. Let's give argument name as number, and then within a method, let's write the logic to find the factorial of a number. So initially, let us declare factorial variable as 1, and then let's create a for loop to iterate over numbers. So here int I equals to 1, the factorial should start from the 1, and then I less than equal to number, and then I plus plus. Alright, and within a for loop, factorial equal to factorial, and then multiply by I. Simple logic. And finally, let us return the factorial. Perfect. Now we have created factorial method. It finds the factorial of a number and return the factorial. Perfect. Next, what we need to do is we need to unit test this factorial method. For that, we are going to write the JUnit test case. So let us go and let us first create a test class. So here we have a factorial class. In order to create a test class for this class, just select this class, right click, show context actions, and click on this create test, and class name is factorial test. So let us keep as it is, and destination package. So let us give net.javaguides.annotations. We keep all the annotations related code inside this package. Next, go ahead and click on OK. Well, notice here the annotations package is created. Within that, a factorial test class is created. Okay, perfect. So this is the test class. Within a test class, let's create a test method. So here public and then void. Let's give a method name as factorial test. Perfect. So this is the normal method. Let us make this method as a test method by using @test annotation. So we just have to annotate this method with @test annotation from org.junit.jupyter.api package. Alright. So basically we use @test annotation to mark this method as a test method. Next, JUnit will automatically identify this method as a test method and it will execute. Okay, perfect. Next, within this test method, let's create an instance of factorial class. Next, factorial class has a method factorial. So let us call factorial method and then pass the number, let's say 5. We want to find the factorial of number 5. Okay, next this factorial method returns the factorial. For that, let's declare one local variable int actual result. Perfect. Next, we need to verify whether the actual result is correct or not. For that, let us use assert methods. So let us use one of the assert method, that is assertEquals. So this assertEquals method we use to verify that the expected value is equal to actual value. And notice here there are multiple overloaded assertEquals method and we need to choose the appropriate one. In our case, we need to choose the assertEquals method. It takes a parameters of type int. So let us select the first one, and notice here assertEquals method first takes expected and then second argument actual. Okay, so let us select this method and then pass the expected result 120. As we know that the factorial of number 5 is 120, so we are expecting that the actual result should be 120 and then pass actual result. Alright, so this assertEquals method verify that the expected value is equal to actual value. If the expected value is equal to actual value, then this test will pass. If the expected value is not equal to actual value, then the assert fails and this test will be marked as a failed. Okay, next let us go ahead and let's run this JUnit test case and then let us see the result, and there we go. You can see test passed because the factorial of number 5 is 120 and the expected value is equal to actual value. That's why the test is passed. Next, let us say we give the wrong expected result, then this test should fail. For example, if I run this test again, you can see test failed because the expected is 121 but was 120. Okay, next let us find the factorial of number 1. Basically the factorial of number 1 is 1, right? And we are expecting the value 1. Next, let us run the JUnit test case and there we go, test passed. Next, let us verify the factorial logic by passing number 2. So factorial of number 2 is 2 and then run the test case and there we go, test passed. Next, factorial of number 4 should be 24. Let's run the test case again and there we go, test passed. It means the factorial related logic we have written in a factorial method is working as expected. So this is how we can unit test the factorial logic by writing the unit test case like this. Alright, so let us summarize the important points about @test annotation. Well, we use @test annotation to mark a method as a test method, and JUnit will automatically run all the test methods which are annotated with @test annotation. So basically, when we create a multiple test methods within a test class and we run the test class, then JUnit will automatically detect all the test methods within a test class and it will run automatically. We don't have to manually run each test method one by one. Okay, and next in JUnit 5, the test method can be a public, protected or default. For example, here we have a test method with visibility public. So if I remove this public and make this test method as a default, and if I run the test case, this should work. Okay, next we can make this test method as a protected as well, protected, and if I run the test again, you can see test passed. It means in JUnit 5 onwards, we can make the test method as a public, protected or default. Next, here the test class, we can make this test class as a public, for example public, and if I run the test class, it should work. Okay, if I make this test class default, it should also work, and if I make this class as a protected, this won't work. Alright, it means the test class should be public or default. Okay, so remember this visibility of test class as well as test methods. Alright, so this is all about @test annotation. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into one of the important assertion method, that is assertTrue method. The assertion class provides a static assertTrue method. This method helps us validate that the value supplied to it is true. This method takes actual value and checks whether it is true or not. If the actual value is true, the test case will pass. If the actual value is false, then test case will fail. So let us go to the API doc for this assertTrue method and let us verify all these points. So go to the browser and in a new tab, just type JUnit Assertions Java doc. So basically this is from JUnit 5 and hit enter and go ahead and choose the latest version, that is JUnit 5.11.0. Alright, so JUnit 5 has an assertion class and it has a static method assertTrue. So here just click on this method and just search for assertTrue method. So look at here is a assertTrue method and it is a static method. And this assertTrue method checks the supplied condition is true. And notice here there are overloaded assertTrue methods. So these are the 6 overloaded assertTrue methods and we'll see all of them with an example. Okay, so just remember assertTrue method we use to verify that the supplied condition is true. Let's go to IntelliJ IDEA and let us see assertTrue method in an action. So let us head over to the IntelliJ IDEA over here. And here go to the base package and here let's create the class under test first. So for that, let's first create a student class. Within a student class, let's create a instance variables, public int id and then public string student name. So let us keep these two fields as of now and let's quickly create a constructor, generate constructor and choose these two fields, click on OK. Next let us also create a getter setter methods, right click, generate and click on getter and setter, choose the fields and click on OK. Perfect, now we have created a student class. Next let's create one more class and let's give name as student service. So this is basically a class under test. Within a student service class, let's create a method. It will return a list of students. So before that, let's declare a list of student instance variable. So list of type student, let's call it as students equal to new array list. Perfect. Next let's create a method. It will return a list of students, public list of type student. Let's give method name as get students and just return this dot students. Perfect. So here is a typo. Instead of string, let us pass student. Perfect. Now we have created get students method. Next, let's also create one more method, public, and then void. Let's give method name as add student. Next, pass student as a parameter, student, and then here let's call students dot add and then pass student. Perfect. Next, let us go ahead and let us write the JUnit test case to test this get students method. So in order to create a test methods, we need to first create a test class. So just select this class, right click on it, show context actions, click on this create test, and here keep class name as student service test. Destination package, let us give net.javaguides.assertions. We keep all the assertions within assertions package. Next, click on OK. Now we have a test class. Within the test class, let's create a test method. So here just type public and then void. Let's give method name as get students test. Perfect. Next, let us make this method as a test method by annotating it with add test annotation. Perfect. Next, within this method, let's create an object of student service equal to new student service. Next, let's have a list of type student, and let's say list of students, and then call student service. It has get students method. Perfect. So this get students method basically returns a list of students, right? Next, let's create a local variable of type boolean actual result equal to list of students dot is empty. So basically here we are checking the list of students is empty or not. Okay, so as of now you can see this get students method returns empty list because we haven't added any students to the list, isn't it? Next, here let us go ahead and let us use assertTrue method to verify that the list of students is empty. So for that, let us go ahead and let us type assertTrue. So notice here there are multiple overloaded assertTrue methods and we have to choose the appropriate one. In our case, first we are going to test this assertTrue method. It takes single parameter. Okay, so go ahead and choose this assertTrue method and then pass actual result. So notice here the actual result is of type boolean, right? And this assertTrue method basically verifies that the supplied boolean condition is true. If the supplied boolean condition is true, then this test will pass, and if the supplied boolean condition is false, then this assert fails and this test method will be marked as a failed. Okay, for example, if I run this test case, you can see the output test passed because the actual result is true. Next, let us go ahead and let us add one of the student to the list and let us see how this assertTrue method behaves. So here let's create a student object, student equal to new student and pass student id 1 and let us say name Ramesh. Perfect. So let us see what is the typo here, name id. So let's go to student class, and here in the constructor we have given the name first. So let us give id as a first parameter and name as a second parameter. Okay, perfect. And here also you can order the declarations, id first, name second. Okay, perfect. Let's go back to student service test. Okay, now we have a student object. Let's add this student object to the list. So here just call student service. It has add student method and then pass student object. Now we have added a student object to the list. Next, when we call the get students method, it returns a single student in the list. and this is method will basically returns a false because the list is not empty, right? Next, if I run this test case, it should fail. So notice here the output test failed because expected is true but was false. Alright, so this is empty basically returns a boolean value false, and this actual result contains a value false, and we are passing the boolean value false to the assertTrue method. Okay, so basically this assertTrue method verifies that the supplied boolean condition or a value should be true. If it is false, then the assertion fails and it marks the test case as a failed. So that is what we can see in the output. Okay, perfect. Now we understood the assertTrue method, it takes single parameter. Next, let us see the other overloaded methods. So here let me comment out this, and here let's call assertTrue, and let us call this assertTrue method, it takes boolean supplier as a functional interface. So boolean supplier is a functional interface, and we have to provide the lambda implementation for the boolean supplier interface. So let us have a lambda syntax, and the lambda has a body actual result. Alright, so basically here we are using boolean supplier because the boolean supplier logic will be evaluated lazily. It means the assertTrue method will execute this logic only if it is required. Alright, so this basically supports Java 8 features like lambda expression, functional interfaces, and all those stuff. So in order to support lambda expressions and functional interfaces, this method was introduced. Next, let us go ahead and let us run the test, and you can see the output test failed because this actual result contains a value false. If I don't add student to the list, then the list is empty and this actual result contains value true, and then this test will pass. For example, if I run this test case, you can see test passed. Okay, perfect. Now we have seen the usage of assertTrue method, it takes boolean supplier functional interface. Next, let us see other overloaded methods. Let me comment out this, and here just call assertTrue method. It takes two parameters. First parameter is a boolean condition, second parameter is a message. So just select this method over here and just pass actual result as a first parameter. Second parameter is the custom message. Let's give the custom failover message. List of students is empty, something like that. And right now the actual result contains the true. That's why the message we won't see in the console. For example, if I run the test case, this test case will get passed, and you can see the custom error message haven't printed in a console because the test has passed. If the test failed, then JUnit will display the report with this custom failover message. For example, let us say we add a student to the list. Let me uncomment this. Now we have added Ramesh student to the list, and this is empty method return false, and now we are passing false value to the assertTrue, and then this is the message. In this case, the assertTrue method will get fail, and it will mark this test as a failed. For example, if I run this test case, you can see the test failed, and you can see the custom message list of student is empty. So whatever the custom failover message we have given here, that is what printed over here, and then expected true but was false. False because we have added a student to the list, that's why it says false. Okay, so this is how, if we want to add some more details to this failed test, then we can go ahead and give those details in the message section. Alright, and those details we can see here in a results whenever the test got failed. Alright, so this is the usage of this assertTrue method. It takes two parameters. Next, let us see other overloaded methods. Just type assertTrue, and next let us call this assertTrue method. It takes boolean supplier with message. So just call this method and then pass lambda expression implementation of boolean suppler. So this is the lambda symbol, and then pass actual result in the body. This is the post parameter. Second parameter is the message. So let us give message something like list of students is empty. Well, notice here the post parameter is the boolean suppler functional interface. So this boolean suppler implementation will be evaluated lazily. It means this logic will be executed only when the assertion is executed. So this logic won't be executed initially. When the assertion is executed, that time this boolean suppler implementation logic will be evaluated. Next, if the boolean suppler implementation returns boolean value true, then this assertion passes, and then JUnit test case will be passed. If the boolean suppler returns the value false, then assertion false, and then test case should be failed. Alright, so test case should be failed with this custom failure message. For example, if I run the test case, you can see the result. List of students is empty because expected true but was false. Next, let us go ahead and let us explore other assertTrue overloaded methods. So let me comment out this, and here just type assertTrue, and in this case let us choose the assertTrue method. It takes boolean condition and suppler functional interface. So let us pass first parameter as actual result, second parameter as the implementation of suppler functional interface. So supply is the functional interface, and we have to provide the lambda expression implementation to the suppler functional interface. So here is the lambda syntax, and let us pass message in the body, list of students is empty. Well, notice here the second parameter, suppler functional interface implementation. So this logic will be executed whenever the test case will fail. If the test case will fail, then this logic will be evaluated and this message will be printed in the results. If the test case will get pass, then this logic won't be executed and this message won't be printed in the results. So basically this logic will be evaluated based on the test case status, like whether the test case passes or fail. For example, if I run the test case, you can see the test phase failed because the actual result contains the value false because the list is not empty. Okay, we have added a student to the list and list is not empty. That's why the assertTrue methods evaluates the actual result, and if the actual result is false, then the test case will get fail. And look at here the message, list of students is empty in a result. Okay, if the test case will get pass, then this message won't be printed. For example, let me comment out this add student logic. Let me save it. Let me run the test case again, and you can see test passes. Alright, next let us go and get to see one more assertTrue overloaded method. So let me comment out this, and here just type assertTrue, and in this case choose this one. First parameter is a boolean suppler, second parameter is a suppler functional interface, and just use the lambda expression implementation for this supplier, boolean supplier, and then use lambda implementation for suppler functional interface. So here is the lambda syntax, and then pass message in the body, list of students is empty. Perfect. Next, here you can see list of students is empty. That's why this assertion will get pass and the test will get pass. And if I run the test case, this should pass. Alright, test passed. Next, if I add a student to the list, then this test should fail because the actual result contains a value false. Next, if I run the test case, you can see test failed and the custom failure message. Alright, so this is how we can use multiple overloaded assertTrue methods to evaluate or verify the boolean condition. In next lecture, we'll take a look into one more assertion method, that is assertFalse method. So assertFalse method is opposite to this assertTrue method. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into assertFalse method. So assertFalse method works exactly opposite to assertTrue method, which we have discussed in the previous lecture. So notice here, assertFalse method is a static method in a assertions class. Next, assertFalse method verifies that the supplied condition or a given condition should be false. If the supplied condition is false, then the test case will pass. If the supplied condition is true, then the test case will fail. And notice here there are multiple overloaded assertFalse methods. Let us go and let us understand assertFalse method with examples, and we'll take a look into all these assertFalse overloaded methods. So let us head over to the IntelliJ IDEA. Let's go to our project, and here go to student service test class over here. And within this student service test class, let's create a test method to demonstrate the usage of assertFalse method. Just type public void, let's give method name as get students test using assertFalse. So basically the test method name should not be like this. The test method name should be get students test. But here we are going to demonstrate the usage of assertFalse method. That's why I have given the name to this test method like this. But ideally in real-time projects, we should give the test method name like this, get students test, because this test method is going to test the logic of this get students method, right? Next, let us make this method as a test method by annotating it with add test annotation. Perfect. Next, within this method, let's create an instance of student service class. Next, here let us have a local variable of type list. List is generic. Let us pass student as a type. Let's give name as student list, and then student service dot get students. Perfect. Next, here let us have one more local variable of type boolean, and then actual result equal to student list dot is empty. So this is empty method returns true if the list is empty, otherwise it returns false. Next, let us go ahead and let us use assertFalse method to verify that the actual result is false. So here just type assertFalse, and notice here there are multiple overloaded assertFalse method. So let us choose the post one and then pass actual result. Well, we use assertFalse method to verify that the supplied condition is false, and in this case the actual result contains the boolean value true. That's why this test case will fail. For example, if I run this test, here you can see the result test failed because the list is empty, and this assertTrue method expect that the actual value should be false because the expected value is false but the actual value is true. Okay, you can see the message in the report like expected false but was true. Next, let us add one of the student to the list. Student equal to new student, and then pass id 1 and then name Ramesh. Next, let us add this student to the list. Students dot add student and then pass student. Now we have added student to the list. In this case, this is empty method returns false. Next, assertFalse method takes the supplied condition, that is actual result. It contains boolean value false. This assertion should pass, and then eventually the test case should pass. For example, if I run the test case, you can see the output test passed. Okay, it means we use assertFalse method to verify that the supplied condition is false. Okay, perfect. Next, let us see the other overloaded assertFalse methods. So let me comment out this, and here just type assertFalse, and let us use this assertFalse method. It takes two parameters. First one is condition of type boolean, second is message of type string. Next, let us pass first parameter is actual result of type boolean, second parameter is the custom failure message. So here let us give message something like student list should not be empty. Perfect. So this assertFalse method assert or check the supplier condition is false. If it is false, then the test will pass. Otherwise, the test will fail with this custom failure message. For example, in this case, the actual result contains value false and this test will pass. For example, if I run the test case, you can see the test passed because the student list is not empty. Okay, next, if I remove the student from the list, now the list is empty and the test case will fail with this custom failure error message. For example, if I run the test case, you can see in the report student list should not be empty. So this is a custom error message we have given to the assertFalse method, and that is what printed over here. And you can see the result expected false but was true. Okay, so this is how you can pass the custom failure message. If you want to provide more details about the failure result, then you can go ahead and add to the message. Next, let us go ahead and let's explore other overloaded methods. So here just type assertFalse and then call this assertFalse method. It takes boolean supplier functional interface. Well, boolean supplier functional interface is an interface, and we have to provide the lambda expression implementation for boolean supplier functional interface. So here is the lambda expression, and let us pass actual result in the body. Notice here this boolean supplier condition will be evaluated lazily. It means this condition will be executed only when the assertion is executed. Okay, next, if I run the test case, this should fail because the expected is false but was true. If you can notice here, the list is empty and the actual result contains value true. That's why the assertFalse method assert that this condition is true. That's why the test case failed. If I add a student to the list, then the actual result boolean variable contains value false, and then this eventually the test case should pass. Okay, next let us go ahead and let us see other overloaded methods. Let me comment out this and then just type assertFalse here. Next, let us take this assertFalse method. This one, it takes boolean supplier as a first argument and string message as the second parameter. Let's use lambda expression to implement boolean supplier functional interface. So here is the lambda syntax, and then pass actual result in the body. Second parameter is the message student list should not be empty. Next, let us run the test case, and you can see test failed with a custom failure message student list should not be empty, expected false but was true. Well, this actual result contains value true, and the assertFalse method expect the supplied condition value is false. That's why this assertion fails and eventually the test case failed. Okay, next let us explore other overloaded assertFalse method. So just type assertFalse and then choose this one that takes boolean parameter as a first parameter and supplier functional interface as a second parameter. So just pass actual result. Second parameter is the implementation of supplier functional interface. So let us use lambda expression to implement supplier functional interface, and here just pass the message in the body. Let me copy this and let me paste it over here. So this supplier functional interface logic will be evaluated lazily. It means this supplier functional interface implementation logic will be executed only when the test case will fail. Otherwise, this logic won't be executed. Okay, so in this case, the test will fail because the actual result contains value true, and this message will be this logic will be evaluated and this message will be printed in the results. For example, if I run this test case, you can see test failed and the message is displayed in the results. Student list should not be empty. Well, if I add the student to the list, and now this actual result contains the boolean value false, and this assertFalse method will check whether the actual result is true or false. If it is false, then this assertion will pass and eventually the test case will also pass. And now in this case, the actual result contains false. That's why this logic won't be evaluated, because the test case will pass. For example, if I run the test case, you can see test passed. Alright, next let us explore other assertFalse methods. So here just type assertFalse and then choose this one. Boolean supplier as a first argument and supplier functional interface as a second argument. So here just pass the lambda implementation of boolean supplier and then lambda expression for this supplier functional interface. Perfect. Next, let us run the test case. This should pass because the list is not empty. Alright, next, if the list is empty, then the test will fail and eventually this message will be displayed in the results. For example, if I run the test case, you can see test failed and this custom failure error message is displayed in the results. Alright, so this is how we can use assertFalse method to verify that the supplied condition is false. Alright, perfect. In next lecture onwards, we will explore more assertion methods. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will take a look into assertNull method. Well, the assertions class provides the static assertNull method, which helps us to validate that the actual object is null. Well, whenever you want to verify that the actual object is null, then you can go ahead and use assertNull method to assert the actual object is null. This method takes actual object and checks whether it is null. If the actual object is null, then test case will pass. If the actual object is not null, then the test case will fail. Alright, so it's simple. Whenever you want to verify that the actual object is null, then you can go ahead and use assertNull method. Next, let us take a look into few overloaded assertNull methods. So let's go to Java doc of this JUnit framework. So here you can see this is the assertions class. Within that, there are few overloaded assertNull methods. So these assertNull methods are static methods. You can see here. So first overloaded assertNull method takes single parameter of type object. And second overloaded assertNull method takes two parameters, actual object and the message. So this message basically this message field basically we can use to add the custom error message. So whenever the test case will fail, then this custom failure message will be displayed in the report. Third overloaded method, assertNull, it takes two parameters. First is actual object, second is a supplier functional interface. And this supplier functional interface is a functional interface and we have to use the lambda expression to implement this functional interface. This supplier functional interface implementation will be evaluated lazily. It means if the test case fails, then only this supplier functional interface implementation will be executed and this message will be shown in the result. Alright, so these are the three overloaded assertNull methods. Let us go ahead and let us understand all these overloaded assertNull methods in action. Let us head over to the IntelliJ IDEA and let's go to our project. And first what we will do, we will create a method and then we will test that method by writing the JUnit test case. So go to the student service class over here And within a student service class, let's create one method which we call basically as a method under test, right? So public, let's give return type as student. Let's give method name as get student by ID, and then let us pass student ID as a parameter. Perfect. So here we have a list of students. Let us iterate over list of students and filter the particular student with student ID. So this is the list. So just call students. Alright. So list has a stream method. So let us call stream method over here. Next, stream has a filter method. So let's call the filter method over here. And look at here, filter method takes predicate as a functional interface, and we have to provide the lambda implementation for this predicate functional interface. So just call this filter method and then pass the lambda expression over here. So just pass student object as a parameter to lambda implementation and then lambda symbol, and in a body just write the condition like student dot get id equal to student id, then return the student. For that, let us call find first method. It returns the student object, first student object from the stream. Next, if student is not exist in the stream, then we can call or else method and we simply pass null. Next, let us have a return statement over here. Perfect. Now we have written a method get student by id. It return the particular student by id. Next, let us write the test method to test this method. For that, go to student service test class over here, and here let's write the test method. Public void, let's give method name as get student by id test using assertNull. Alright, next let us make this method as a test method by annotating it with add test annotation. So basically this add test annotation mark this method as a test method. Next, within this method, let's create an object of student service. Next, let's create a student equal to new student, and then pass id1, name Ramesh. Alright, and then call student service dot add student to add the student. Perfect. Now we have added one student to the students list. Next, here let us declare one local variable of type student, and let's call it as actual object equal to student service dot get student by id, and then pass id 1. Perfect. So look at here, we have added student with id 1 to the students list. Next, we are getting the same student by using get student by id method, because look at here, we are passing the student id 1. Okay, so in this case the actual object is not null. Next, let us use assertNull method to assert or check whether the actual object is null. So for that, let us type here assertNull, and notice here there are 3 overloaded assertNull methods. Just call the first one, it takes single parameter, and then pass actual object. Perfect. So this assertNull method basically verifies that the actual object is null. Next, if I run this test case, this should fail because this actual object contains the student object. Let us run the test case, and you can see here test failed, and look at the report here, expected null but was the student object. Alright, so basically we have to use assertNull method to check the actual object is null, right? So what we'll do, we'll pass the student id here which is not exist in the list. For example, student id 2. So student with id 2 is not exist in the students list because we haven't added student with ID 2 to the list, right? So if I call this get student by ID method with ID 2, then this should return the null. For example, if you go to this method, you can see if the student with a given ID is not exist in students list, then it should return the null. Okay, perfect. Let's go back to student service test class, go to this method, and now the actual object contains the value null. Okay, and if I run the test case, this should pass. For example, here let us run the test case and look at here, test passed, because the actual object contains a value null and this assertNull method expect the actual object as a null. Alright, perfect. Next, let us see other overloaded assertNull methods. Let me comment out this, and here just call assertNull, and in this case let us call this assertNull method. It takes two parameters. First parameter is the actual object, second parameter is the message. Let us pass actual object as a first parameter, and the message, let us say student object is not null. In this case, the test case should pass because a student with ID 2 is not exist, hence the actual object contains a value null. So if I run the test case, this should pass. Okay, next let us pass the student ID 1, which is there in the list. Now the actual object contains a value, and this assertNull checks whether the actual object contains null or not. If it is null, then the test case will pass, otherwise it will fail. Now this should fail. If I run the test case, you can see test failed, and notice here the message, custom failure message, student object is not null. So this is what printed over here. Okay, so if you want to add more details to the failure test, then you can go ahead and add it to the message field over here. Okay, perfect. Next, let us see one more overloaded assertNull method over here. Just call assertNull, and in this case let us call this assertNull method. It takes actual object and supplier functional interface. Just pass actual object as a first parameter and lambda implementation as a second parameter. Well, supplier is the functional interface and we have to provide the lambda implementation for supplier interface, isn't it? So here just have a lambda implementation and then pass the message in the body. Let us say student object is not null. Okay, perfect. So basically this supplier functional interface implementation will be evaluated or executed whenever the test case fails. Alright, so basically this logic will be evaluated lazily. It means whenever the test case fails, then only this logic will be executed and this message will be printed in the result. Otherwise this logic won't execute. Okay, for example, if I run this test case, this should fail and this message will be displayed over here. Okay, so this functional interface implementation logic will be evaluated lazily. It means whenever the test case fails, then only this logic will be evaluated and accordingly the message will be displayed in the result. If the test case passes, then this logic won't be evaluated and this message won't be printed in a result. For example, let us call get student by ID method with the student ID 2, which is not exist in the list, and the actual object should be null, and in this case the test case will pass. Alright, just remember, if you want to verify that the actual object is null, then you can go ahead and use this assertNull method. In next lecture we'll take a look into assertNotNull method, which is exactly opposite to this assertNull method. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we'll take a look into assertNotNull method, which is exactly opposite to assertNull method, which we were discussed in the previous lecture. Well, the assertions class provides the static assertNotNull method, which we can use to check the actual object is not null. This method takes an actual object and checks whether it is not null. If the actual object is not null, then the test case will pass. If the actual object is null, then the test case will fail. Alright, so If you want to verify that the actual object is not null, then you can go ahead and use this assertNotNull method. And there are a few overloaded assertNotNull methods. So if you go to the documentation over here, and if you can notice here, assertNotNull methods. So there are total 3 overloaded assertNotNull methods, and these are the static methods, and these methods belongs to assertions class. The first assertNotNull method takes single parameter of type object. Second assertNotNull method takes 2 parameters. First is the actual object, second is the message of type string. Third overloaded assertNotNull method takes 2 parameters. First is the actual object, second is the supplier functional interface. Alright, next let us go ahead and let us see these 3 overloaded methods in an action. So let us go to the IntelliJ IDEA and let's go to our project. Let's go to student service test class, and here let's quickly create a test method to demonstrate the usage of assertNotNull method. So here let's quickly create a method, public void, let's give name as get student by id test using assert not null. Perfect. So basically we are going to write the unit test to test this get student by id method, right? Next let us make this method as a test method by annotating it with @test annotation. So basically this @test annotation marks this method as a test method. Next within this method let's create an object of student service class. So here I have already created student service class and one student. Let me quickly copy these lines of code and let me go to again get student by id test using assertNotNull method, and here let me paste it. Okay, so here we have created student service object and then a student object, and we have added that student object, and here we are calling get student by id method and we pass the student id 2. So notice here student with id 1 is exist in the list, but the student with id 2 is not exist. Okay, so let us first pass the student id 1 which is exist in the list. Now the actual object contains the value. Next let us use assertNotNull method to check the actual object is not null. So here just type assert not null, and notice here there are 3 overloaded assertNotNull methods. Let us choose first one, assertNotNull method. It takes single parameter and then pass actual object. So this assertNotNull method verifies that the actual object is not null. Next let us run this test case, and notice here test passed because this actual object contains the value and the expected result should be not null, and the actual result is also not null. That's why the assertion passed, eventually the test case also passed. Next let us say we want to get the student with id 2, and notice here the student with id 2 is not exist in the list because we haven't added that student. We have added only one student, that is student 1. Next if I run this test case, this should fail because this get student by id returns null as this student with id 2 is not exist in the list. Alright, perfect. Next let us explore the other overloaded assertNotNull methods. Let me comment out this, and here just call assertNotNull method, and next let us choose this assertNotNull method that takes 2 parameters, actual object as a first parameter, string as a second parameter, and then pass actual object as a first parameter and message as the second parameter. So let us pass student is null. If this test case fails, then this message will be displayed in the result, and this is basically a cause why the test failed. Okay, the student is null, that's why the test failed. That's why the message student is null. Okay, perfect. Next let us run the test case. Notice here the test failed with a custom message student is null. Okay, so student with the ID 2 is not exist. That's why this assert failed and eventually test got failed. And if I pass student ID 1 here, this should pass because the actual object is not null. Okay, if I run the test case, you can see test passed. Alright, next let us explore other assertNotNull overloaded method. So just type assertNotNull and then choose this method. It takes actual as a first parameter, second parameter as a supplier interface, and then pass actual object as a first parameter and lambda implementation as a second parameter. The supplier interface is a functional interface and we have to provide the lambda implementation for it. So here is the lambda syntax, lambda symbol, and then within a body just pass the message student is null. Well, this supplier functional implementation will be evaluated lazily. It means if the test case will fail, then only this logic will be evaluated and this corresponding message will be printed in the result. If the test case passes, then this logic won't be executed. Okay, so basically in order to support the lazy evaluation and Java 8 features, this supplier functional interface was introduced. Alright, perfect. Next, let us run the JUnit test case, and test passed because the actual object is not null. So this is how we can use assertNotNull method to verify that the actual object is not null. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into assertEquals method. The assertion class provides a static assertEqual method to verify that two values are equal. Well, if you want to verify that the actual value is equal to expected value, then you can go ahead and use assertEquals method. If the actual value is equal to expected value, the test case will pass. If the actual value is not equal to expected value, the test case will fail. Alright, it's pretty simple. If you want to verify that the actual value is equal to expected value, then you can go ahead and use assertEquals method. So there are few overloaded assertEquals method. So let's go to the Java doc and let us see the overloaded assertEquals method. So just go to the API documentation over here and just search for assertEquals, and notice here the overloaded assertEquals method. So there are a lot of overloaded assertEquals methods. So basically you can see the parameter type, byte, char, double. So there are different types of parameters. That's why there are a lot of overloaded assertEquals method. Okay, so we'll take a look into few of them, the important ones basically. Okay, so let us go to the IntelliJ idea and let us learn more about assertEquals method. Let's create a test method. For that, first we'll create a method public void. Let's give method name as get student by ID test using assertEquals. Perfect. Next, let us make this method as a test method by annotating it with @test annotation. This annotation mark this method as a test method. Next, within this method, we are going to create object of student service as well as the object of student class. Let us copy this piece of code from the existing method and go back to the method again and paste it over here. Perfect. Next, let us use assertEquals method to verify the result of this get student by ID method. So assertEquals method we use to verify that the actual value is equal to expected value. And in this case, the actual object basically contains the actual value. Next, let us use assertEquals method over here. So notice here there are a lot of assertEquals method. So basically the assertEquals method takes different parameters with different types. That's why you can see a lot of overloaded methods. So first let us choose the assertEquals method. It takes two parameters of type int. Okay, let us call this assertEquals method, and then pass the actual value as a 1. So we are going to check the student ID first, and then actual object dot get ID. So here we are using assertEquals method to verify that the student object has a student ID 1, which is actual value, is equal to expected value 1. So if you look at here, the student object has a student ID 1, which is actual value and is matches to the expected value. That's why these assertions will pass. Eventually the test case will also pass. So if I run the test case, you can see test passed, because this assertEquals method verified that the actual object or actual value is equal to expected value. The actual object has a student ID 1 is equal to the expected value 1. Okay, perfect. Next, let us have assertEquals overloaded method over here, and then pass a name Ramesh, and then actual object dot get name. So here we are calling assertEquals method to verify that the student object contains the name Ramesh, which is actual value, is equal to the expected value Ramesh. So in this case, the student has a name Ramesh, which is the actual value, is equal to the expected value Ramesh. So both are equal. That's why this assertEquals method will pass. Eventually the test case will also pass. If I run the test case, you can see test passed. Okay, next let us explore few more assertEquals overloaded methods. So here just type assertEquals. Let us use this assertEquals method. It takes two parameters of type object. So just call this method over here, and here just pass student object as the expected object and the actual object as a actual value. So notice here we are passing the expected value as a student object, and here we are passing actual value as a actual object. It contains the student object with ID 1. So this get student by ID method basically return the student with ID 1. So here basically we are using assertEquals method to verify that the actual object is equal to the expected object. So let us go ahead and let us run the test case, and let us see whether the test passes or not. Yes, the test passes because the actual object is equal to expected object. Next, let us see how we can display the custom failure message in the report. Let us say if test case fails, then we can also display the custom failure message, right? So for that, what we can do is we can call one more assertEquals method. It takes 3 parameters. Post parameter as the expected, second parameter is the actual, and third parameter is the message. So in this case, let us use this assertEquals methods. It takes 3 parameters. Okay, post parameter is the actual, post parameter is the expected, we are expecting student ID 1, second parameter the actual value, that is actual object dot get ID, and then custom failure message. Let us say student ID is not equal. All right, next let us run the test case and let us see. From here let us run the test case, and you can see test passed because the actual object contains the student ID 1, which is equal to the expected value 1. Let us say if the expected value is 2 and the actual object contains student ID 1, so both are not equal, the test will fail and this message will be shown in the result. For example, let us run the test case, and you can see here test case failed, and here is the custom failure message, student ID is not null. So this is how we can use assertEquals method to verify that the actual value is equal to expected value. If both the values are equal, then test case will pass. If both the values are not equal, then the test case will fail. Next, let us use one more overloaded assertEquals method. It takes supplier functional interface. So here just type assertEquals and then pass student name Ramesh and the actual object dot get name. Next, let us use lambda implementation of supplier functional interface as a third parameter. So here just have the lambda implementation and then pass message in the body. Student name is not equal. So notice here, this is the supplier functional interface implementation using lambda expression, and this logic will be evaluated lazily. It means if the test case fails, then only this logic will be executed and accordingly this message will be shown in the report. If the test case passes, then this logic won't be executed and this message won't be shown in the report. Okay, and here we are using assertEquals method to verify that the actual student name, that is Ramesh, is equal to expected value Ramesh. So both the values are equal, so this assertions will pass. Eventually the test case will also pass. So here let me run the test case. So this test failed because due to this assertion. So here just pass the expected 1 because the student has ID 1 here. Let me run the test again and notice here test passed. Okay, so if I give a different name here, let us say Ram, and if I rerun the test case, this should fail because student name is not equal. So this message field is pretty useful because here we specify that why the test case failed. Okay, so what is the reason the test case got failed? So in this case, the student name is not equal, that's why the test got failed. Okay, great. So just remember, whenever you want to verify that the actual value is equal to expected value, then you can go ahead and use this assertEquals method. So this assertEquals method is one of the commonly used method to assert the actual values with the expected values. Alright, great. In next lecture, we'll take a look into assertNotEquals method, which is exactly opposite to this assertEquals method. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into assertNotEquals method. The assertions class provides the static assertNotNull method, which we can use to verify that two values are not equal. Well, if you want to verify that the actual value is not equal to expected value, then we can use assertNotEquals method. If the actual value is not equal to expected value, then the test case will pass. If the actual value is equal to expected value, the test case will fail. So this assertNotEquals method is exactly opposite to assertEquals method that we saw in a previous lecture. Next, let us go ahead and let us see the overloaded methods of assertNotEquals method. So let us head over to the API documentation over here. This is the assertions class. Within that, let us search for assertNotEquals. And notice here there are a lot of assertNotNull equals overloaded methods over here, and all of them are static methods. So in order to support different data types, they have created so many assertNotNull method over here. We will see the important ones. Okay, so basically we use assertNotNull method to assert or check the expected and actual values are not equal. All right, so let us go and let us see the usage of some of the important assertNotEquals method in an action. So let us head over to the IntelliJ IDE over here and go to our project, and here let me minimize this and go to student service test class. Here let us quickly create a test method. So for that, just type public and then void. Let's give a method name as get student by ID test using assertNotEquals. Perfect. Next, let us mark this method as a test method by using add test annotation over here. Next, within this method, let us write the logic to unit test get student by id method. Next, let us create a student service class object, and let's also create one student object, and let us add to the list. Well, if you visit the previous method, here we have created student service object, a student class object, and we have used get student by id method over here. Okay, so let us go ahead and let's copy this piece of code so that we can save some time. And here just go inside this method and paste it. Now we have created student service class object, and we have created student class object, and we have added that student to the list. And then here we are calling get student by id method by passing student id 1. Now this actual object contains a student object. Next, let us go ahead and let us use assertNotEquals method to verify that two values are not equal. If two values like actual value and expected values are not equal, then the test will pass. So here just type assertNotEquals, alright, and then pass the expected value, let us say 1. So let us first verify that the student id is not equal. So here post parameter the expected value 1 and the actual value actual object dot get id. So notice here student has a student id 1 and we are expecting the id also 1. So both are equal, that's why this assert fails and eventually the test case also fail. Okay, so if I run the test case over here, you can see the test fails. Next, here let us pass the expected 2. So basically we want to verify that both the values are not equal, right? So assertNotEquals method we use to verify that both the values are not equal, then only the test case will pass. So in this case the student id is 1 and the expected value is 2. So both are not equal, that's why the test case will pass. For example, here if I run the test case, you can see test passes. Next, let us go and let us use some of the overloaded methods of this assertNotEquals method. So here just type assertNotEquals and then use the method which takes string as a parameters. So just type first parameter as the name Ramesh and then second parameter student name. So notice here the actual value is Ramesh and we are expecting the value Ramesh. So both actual value and expected value are equal, that's why this test will fail. So here we have to use assertNotEquals method to verify that both the values are not equal, right? So here let us change the expected value. Now actual value and expected value are not equal, that's why this test will pass. For example, if I run the test case, you can see the test passed. Next, let us type assertNotEquals and just go down and let us use the assertNotEquals method that takes 3 parameters. Okay, so here let us take this one and here just pass the expected value 1 and student id and then a custom failure message, let us say student id is equal. Alright, so here you can see the actual student object has id 1 and we are expecting the value 1. So both are equal, that's why the test case will fail and eventually this message will be displayed in the report. For example, if I run the test case, you can see test failed and the custom failure message is displayed over here. Okay, next let us change the expected value to 2 and run the test case. This should pass because the actual value and expected value are not equal. Perfect. Next, let us have one more overloaded assert assertNotEquals method over here, and then pass the name, let's say Ramesh, and actual object dot get name. All right, and let us use the supplier functional interface implementation over here. So we have to use lambda implementation or lambda expression to implement supplier functional interface. So here in the body, just pass student ID is equal. Okay, so if you notice here, the actual value is Ramesh, actual value of student is Ramesh, and we are expecting the same name here. So both are equal, that's why this assert will fail, and eventually the test also will fail. For example, if I run the test case, you can see the test is failed, and if you can notice here, the custom error message student ID is equal. Next, if I change the expected value, both are not equal. Now let us rerun the test, and you can see test passed. Okay, perfect. Next, let us see one more overloaded assertNotEquals method that takes an object, okay, assertNotEquals, and then pass student object as a expected value and actual object as a actual value. So this student object here we have created, and we have added this student object to the list by using add student method, and here we are calling get student by ID method by using student ID, and this get student by ID method returns the actual student object, and that is what we are passing over here. Notice here this student object has ID 1 and name Ramesh, and this actual object also has the ID 1 and name Ramesh. So both the objects are equal, that's why this assert will fail, and eventually the test case will also fail. So if I run the test case, you can notice here the test failed, okay, because expected not null but was object. Next, in order to pass this test, we have to pass the different expected value. So here what we can do is we can create one more student, and let's call it as student1, and we can give different values, and here as expected value we can pass student1. Now if I run the test case, this should pass because the expected value is not equal to actual value. Both are different. Well, whenever you want to verify that both the values are not equal, then you can go ahead and use assertNotEquals method. If the actual value and expected value are not equal, then the test case will pass. If the actual value and expected value are equal, then the test case will fail. So this is exactly the opposite to assertEquals method. In next lecture, we'll take a look into assertArrayEquals method. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into assertThrows method in a JUnit framework. The assertThrows method in a JUnit is used to assert that a block of code throws the specific type of exception. Well, whenever you want to verify that a method throws the correct type of exception, then you can go ahead and use this assertThrows method. If the code does not throw the expected exception, the assert fails and the test is marked as failed. If the code throws expected exception, the assertion passes and eventually the test is marked as passed. This basically follows an inheritance hierarchy. The assertion will pass if the expected type is a superclass of the actual exception type. For example, let us say we have student not found exception that extends runtime exception, and here the runtime exception is a superclass of student not found exception. So instead of specifying the student not found exception to this assertThrows method, we can also specify the superclass, that is runtime exception. So in this case also the assertion will pass. Okay, so we'll see this in our example section. Now let us take a look into the overloaded methods of assertThrows method. So here we are in a Java doc of JUnit API, and here is the assertions class. Within that we have a assertThrows method, and notice here there are three overloaded assertThrows method, and these assertThrows methods are static methods. The first overloaded assertThrows method expects two parameters. First one is expected type, second one is executable. Expected type is the exception and executable is the functional interface. For example, if I go inside this executable interface, you can see it is a functional interface and we have to provide the lambda expression to implement this functional interface. And within this executable implementation, we specify the code that throws the expected type. Okay, expected type meaning the method throws the type of exception. Alright. The second overloaded assertThrows method takes three parameters: expected type, executable, and the optional message of type string. Well, whenever the test failed, then the assert will basically add this custom failure message in the report. Next, third assertThrows method expect three parameters: expected type, executable, and the message supplier of type supplier functional interface. This supplier functional is a functional interface and we have to provide the lambda expression implementation for this supplier functional interface. So basically this supplier functional interface implementation logic will be evaluated lazily. It means whenever the test case failed, that time only this logic will be evaluated and accordingly the message will be displayed in the report. Okay, so these are the three overloaded assertThrows method. Let's go ahead and let's understand all these three overloaded assertThrows method with an example. So let us head over to our project in IntelliJ IDEA. So first what we're going to do is we're going to create one custom exception. So go to the base package over here and then right click, new, and then choose Java class. Let's give class name as student not found, F should be capital, not found exception. Perfect. And hit enter. Next, this class extends a runtime exception. Next, within this custom exception class, let's create a constructor, public student not found exception, and then pass message of type string as a parameter to the constructor, and then call super keyword to pass this message to the super class constructor. Okay, perfect. Now we have created student not found custom exception. Next, let's create one method that throws this student not found exception. So let's go to student service class over here and just scroll down, go at the bottom, and here let's create a get student by name method that throws student not found exception if the student is not available in the list. So here just type public, let's give return type as student, and then let's give method name as get student by name, and then here just pass name as a parameter. Next, within a method, let's call students list. It has a stream method, and then call filter method. Notice here filter method takes predicate functional interface and we have to provide the lambda expression to implement this predicate functional interface. So let us have a lambda expression over here, and lambda expression takes student object as a parameter. Next, let us add a condition to filter the student by name from the stream. So here student dot get name, it returns a string and it has equals method, and then pass name. Perfect. Next, let us call find first method to return the first student from the stream, and then call or else throw method. Well, let us say if student with a given name is not available in the stream, then we will throw the student not found exception. So in order to do that, let's call or else throw method, and notice here or else throw method takes supplier as a functional interface and we have to provide the lambda expression to implement this supplier functional interface. So just call this method and let's pass the lambda expression here, new student not found exception, and let's give the custom error message. Let us say student not found with name, and here let us pass the name dynamically. Perfect. Next, let us have a return statement over here. Perfect. Now we have created get student by name method. Within that we have written a logic to get a particular student from the list. If the student with a given name is not exist in the list, then this method throws the student not found exception. Next, let us go ahead and let's create a JUnit test case that will test this method. And this method basically throws this student not found exception, and we'll use assertThrows method to check whether this method throws this correct student not found exception or not. Next, let's go to student service test class over here, and within that let's create a test method. So here just type public void, let's give method name as get student by name test using assertThrows. Perfect. This is the normal method. Let's make this method as a test method by annotating with it add test annotation. So this add test annotation mark this method as a test method. Next, within this method let's create a student service class object. Student service equal to new student service. Next, let us go ahead and let's create one student object over here. Student equal to new student, and let's pass values to the constructor. Student ID 1, student name Ramesh, and then department science. Alright, next let us go ahead and let's add this student to the student list by using student service dot add student method. Perfect. Now what we're going to do is we're going to use assertThrows method to verify that the get student by name throws the correct type of exception or not. Well, if you go to student service, here we have created get student by name method, and this method throws the student not found exception if the student is not available in the list, right? So basically we are going to verify that this method throws this correct student not found exception or not by using assertThrows method. Alright, so let's go back to student service test class over here, and here just call assertThrows, and notice here there are 3 overloaded assertThrows methods. Okay, so let us go and let's call this assertThrows method. It takes 2 parameters, expected type and executable. So first parameter is the expected type. In our case, the expected exception type is student not found exception. So just type student not found exception dot class. Second parameter is the executable functional interface, and we have to provide the lambda expression implementation for executable functional interface. So here is the lambda implementation, and within this lambda implementation we have to write a block of code that throws the exception. So here basically call student service dot get student name and then pass student name Ramesh. So this is the line of code that throws the student not found exception if the name is not present in the list, right? So make sure that you add a block of code that throws the exception within this lambda body. Next, put the semicolon. Now we have used assertThrows method to verify that this get student by name throws the correct type of exception, that is student not found exception or not. And here we are passing the student name Ramesh, and the student with the name Ramesh is already exist in the list. So this get student by name don't throw the student not found exception. Hence, if I run this test case, this will fail because the get student by name don't throw the student not found exception because this student Ramesh is already exist in the students list. For example, if I run the test case, you can see test failed because the student not found exception is not thrown by this method. Okay, next, if I pass the different student name who is not exist in the list, then this method should throw the student not found exception, isn't it? Now let me run the test case, and here you can see test passed. It means this get student by name throws the correct type of exception, that is student not found exception. So this is how we can use assertThrows method to verify that the method throws the correct type of exception. Okay, next, if I pass the different type of exception over here, let us say null pointer exception, and if I run the test case, this should fail because unexpected exception type thrown, expected null pointer but was student not found exception. Okay, it means this get student by method throws the student not found exception, but here we have specified the type null pointer exception. So both are not matching. That's why the assertion fails and eventually the test case also failed. Alright, so this is how we can use assertThrows method to verify that the getStudentByName method throws the correct type of exception. Alright, so let me pass student not found exception here, and let us go ahead and let us see the other overloaded assertThrows method. So here let me copy this and let me paste it over here, and let me comment out this. So this assertThrows method takes three parameters. First parameter is the expected type, second parameter is the executable interface implementation, and third parameter is the message, custom message, right? So here let us pass the message student not found exception, student not found exception should be thrown, but it wasn't, something like that. Alright, so here basically we are using assertThrows method to verify that this method throws the student not found exception. If this method does not throw the student not found exception, then this assert failed and eventually the test case will fail and this message will be displayed in the result. For example, if I run this test case, this should pass because the student with the name Umesh is not exist in the list, and this method throws the student not found exception. If I pass the student name who is existing in the list, then this method don't throw the student not found exception and this assert will fail and eventually the test case will fail. So here let me run the test case, and you can see test failed because student not found exception should be thrown but it wasn't. That's why the test has failed. Okay, great. Next, let us see one more overloaded assertThrows method. Let me copy this, comment out, and here let me paste it over here. Third parameter in this case is the supplier interface, and we have to use the lambda expression to implement the supplier functional interface. And this supplier functional interface implementation logic will be evaluated lazily. It means whenever the test case fails, then only this logic will be executed and this message will be displayed in the result. For example, if I run the test case, the test failed and this message is displayed in the result like this. Okay, and if the test case will pass, then this logic won't be executed and this message won't be displayed in the result. Now we have seen the overloaded three assertThrows methods over here. Next, let us see the inheritance hierarchy. Well, if you go to the student not found exception, it extends the runtime exception, and in this case the runtime exception is the superclass and student not found exception is the subclass. And this assertThrows method passes if we specify the parent class of this student not found exception as well. For example, here let me pass the runtime exception as a superclass, and if I run the test case, this should failed because student not found exception should be thrown but it wasn't. Expected runtime to be thrown. For example, if I pass the student who is not existing in the list, then this getStudentByName should throw the student not found exception, and which is again the subclass of this runtime exception. Now let me run the test case. This should pass because the getStudentByName throws the student not found exception, and which is again the subclass of runtime exception. Okay, so this assertThrows method supports the inheritance hierarchy like this. Alright, great. So this is all about the assertThrows method. Well, whenever you want to verify that the method throws the correct type of exception, then you can go ahead and use this assertThrows method. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will see how to display test names by using @displayName annotation in a JUnit. The @displayName annotation is used to define a custom name for a test method or a test class. Well, displaying meaningful test names can make test results more readable and understandable especially when running a large suite of test cases. This annotation helps provide descriptive names that improves the readability of test results. By default, the test class name and test method names get printed when the test case is executed. Well, when we execute the JUnit test case, by default, the test name or class name gets printed in the results, right? But by using @displayName annotation, we can customize the name of the test method as well as the test class. We'll see an example how we can customize the test name and test class. @displayName annotation takes string with the spaces between words, special characters and emojis as well. So we can pass the sentence, it contains special characters and emojis to the @displayName annotation. Alright, so let us go ahead and let us understand more about @displayName annotation with example. So let us head over to the IntelliJ IDE and go to our project and go to the calculator class over here. So within this class we have add method. Next let's go ahead and let's add a couple of more methods to this class. So here just type public and then give return type int, and let's give method name as subtract, and let's pass the parameters int a comma int b, and let's have a return statement return a minus b. Perfect. Similarly, let's create a method for multiplication. Let me copy paste it, and here let me change the method name multiply, and here let's change the logic a into b. Okay, next similarly let's create one more method for division. So here let's give the method name as divide. Okay, and here let's change the logic a divided by b, and here we can also add the statement like if b equal to 0, then we'll throw the exception. So here throw new arithmetic exception, let's say division by 0, something like that. Now we have created a calculator class. Within that we have created add, subtract, multiply and divide methods. Next let us go and let us unit test all these methods using JUnit. So go to the test package, go to the annotations package over here, right click on it, new, and then give class name as calculator test. Alright, and within this test class let's create a test methods. So here just type public void, let's give method name as add test. Next let us mark this method as a test method by annotating it with @test annotation. Next we can also reduce the visibility of this method by removing this public. Next within this add test method let's create an instance of calculator class. Next let us call add method calculator.add and then pass 2, 3. Next let's take a result of this add method in a local variable of type int, and let's give method name let's give local variable name as addition. Next let us use assertEquals method to verify that the actual result is equal to expected result. So here just type assertEquals, and here look at here the import is not coming. So if the import is not coming, then we can explicitly import this assertEquals method. And notice here assertEquals method is a static method, right? And this method is from assertions class. So here just type import static org.junit.jupyter.api.assertions.star. Perfect. So we are basically importing the static methods from this assertions class. Now if you go to assertEquals and just press Ctrl space, you will get a options. Okay, next select this assertEquals. Next, let us pass the expected value 5. We are expecting that 2 plus 3 is 5, and then actual value addition. Perfect. Next, let us run the test case, and you can see test passed because the the actual value is 2 plus 3 5, and the expected value is 5. So both are equal. That's why the test passed. Notice here, by default, the test class name and test method names gets printed in the result. Okay. Next, let us say we want to customize the test class name and test method names. Then we can go ahead and use @displayName annotation. Alright, for example, here let us first customize the test class name by annotating it with @displayName annotation. Next, let us pass the custom name. Let us say calculator operations test. Okay. Next, let us go ahead and let us also customize the test method name by using @displayName annotation over here, and let us pass the custom name to this test method as test addition of 2 numbers. Perfect. Next, let us go ahead and let's run the JUnit test class, and you can see here in the result the custom names are printed. Okay, calculator operations test. So this is the custom name we have given to the test class. Test addition of 2 numbers. This is the custom name we have given to the test method. Okay, now you can see this is the descriptive meaningful name that we have given to the test class as well as test method. So this is how we can use @displayName annotation to customize the name of test class as well as test methods. Okay, perfect. Next, let us also write a couple of JUnit test cases to test other calculator operations. So here, let me simply copy this JUnit test case and let me paste it over here. And here, let's change the test method name. Let's say subtract test, and here just call subtract method, and then pass 3 A3 B2 and assertEquals expected 1, and just change the local variable name. Let's call it as subtraction, and then remove the addition and just pass subtraction. Perfect. So here we used assertEquals method to verify that the expected value is equal to actual value, and you can see the logic 3 minus 1 1. So that is what we have given as expected. Okay, and here let's give a meaningful name to this test by using @displayName. So here let me change the display name something like test subtraction of 2 numbers. Okay, perfect. Next, let us run the test, and you can see the custom name for this test method is displayed in the result, test subtraction of 2 numbers. Next, we can also pass the special characters and emojis as a string to this @displayName annotation as well. For example, let me pass the special character to this custom name $%. Okay, and if I run the test case, you can see the custom name supports special characters. Okay, even we can also pass the emojis as well. For example, let me go to browser and just let me browse for emojis. Emoji, click on the post link, and let's get one of the emoji. So here just search for smiley face, and just take this one and just copy it, go back to test, and here just paste it and run the test case, and you can see the emoji. Alright, so this is how we can use @displayName annotation to give a meaningful name or a descriptive name to the test class as well as test methods. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into how to disable the tests using @disabled annotation in a JUnit. Disabling test allows you to prevent specific test methods or specific test classes from being executed during a test run. Well, this can be useful in a scenarios where a test cases is not ready, needs to be temporarily skipped due to known issue, or when refactoring the code. Disabled annotation is used to disable or skip a test method or a test class. The JUnit will skip the execution of disabled annotated test methods or all test methods within a disabled annotated test class. Well, whenever you want to skip some of the test methods, then you can go ahead and annotate those test methods with disabled annotation, and you can also skip all the test methods within a class by annotating that class with disabled annotation. We will see an example how we can achieve all these things. Why disable tests? Well, there are several reasons why you might want to disable test cases. Known issues. If a test is falling due to known bug or issue that you are working on, you might disable the test until the issue is resolved. Incomplete features. If a test is for a feature that is not yet fully implemented, you might disable the test until the feature is complete. Refactoring. When the refactoring code, you might temporarily disable tests that are affected by the changes until the refactoring complete. External dependencies. If a test relies on external service or a resource that is currently unavailable, you might disable the test until the dependency is back online. Okay, so these are some of the scenarios where you can disable the test cases. Next, let us go and let's understand how to disable the test using disabled annotation in action. So let's go to IntelliJ IDEA and go to our project, and here we have a calculator class. Within that we have a couple of methods: add, subtract, multiply and divide. Next, let us create a test class and we'll write a JUnit test cases to unit test all these methods. So go to test package, go to base package over here, go to annotations package, right click on it, new, and then choose class. Let's give class name as disabled calculator test. Well, here I am demonstrating the usage of disabled annotation, that's why I have given the test class name like this. But ideally the test class to test the calculator naming convention should be calculator test. Okay, perfect. Next, within this test class, let's go ahead and let's create a test methods. So just type void and then add test is the method name. Next, let us annotate this method with add test annotation to mark this method as a test method, and within this method let's create an instance of calculator class. Next, let's call calculator.add method and then pass 2,3. Next, let's use assertEquals method to verify that two values are equal. So here assertEquals import is not coming. We can explicitly add the import static org.junit.jupyter.api.assertions, and then star means we can import anything from this assertions class. Perfect. Next, you can go to assertEquals method and just press Ctrl space. You can get all the overloaded assertEquals method over here, and just select first one and then pass expected value 5, and here the actual value should be the result of this add method. So let us take the result of add method in a local variable of type int, and let's call it as addition, and here just pass the actual value addition. Okay, so this assertEquals method here we are using to assert or verify that the actual value is equal to the expected value. As we know that the actual value is 2 plus 5 and we are expecting the same as 5. Okay, perfect. Next, let's create a couple of more JUnit test cases. Public, we can reduce the visibility, we can keep default, just type void and then subtract test. So this is the test method that we are going to use to test subtract method from calculator class. Next, let us annotate this method with add test annotation. Within this method, let's create an instance of calculator class. Alright, and then int subtraction calculator dot subtract, and then pass 3,2, and then let's use assertEquals, and then expect 1 actual subtraction. Notice here we are using assertEquals method to verify that actual value is equal to expected value, and here the actual value is 3 minus 2 1, and we are expecting same here 1. Okay, next let us run the test class from here, and you can see the result, tests are passed. Okay, next let us create one more test case. Just copy it, paste it, and here let's give the method name multiply, and here let's call multiply method from the calculator class, and then pass 2, 3, and here let us change the local variable and let's call it as multiplication, and here just pass this multiplication, and we are expecting 3 into 2 6. Perfect. Next, similarly, let's create one more test case. Just copy it, paste it, and here let's give method name as divide, and then just call divide method of calculator class 5 or 10, 5, and here expected 2, and just change the local variable. Let's call it a division, and here also division. Perfect. Next, let us run the complete test class, and you can see all the tests are passed. Okay, now we have created a base. Next, let's understand how to use add disabled annotation to disable the test method. So let us say we want to disable this add test method. Then we can annotate this method with add disabled annotation from org.junit.jupyter.api package. Next, if I run the test class, you can see here add test method is disabled. Okay, next we can also optionally pass the string to this annotation as well. For example, let's say disabled until bug let's give some bug name, let's say 40 is fixed. Alright, so this is the optional. You can pass the message to this annotation saying that why you are disabling this particular test method. Okay, and if I run the test case, you can see the test method is disabled, and you can see the message disabled until bug 40 is fixed. Okay, so this is how you can also pass the message or information saying that why this particular test method is disabled. Next, we can disable multiple test methods within a test class. For example, here let us disable this subtract test method as well. So here just annotate this method with add disabled annotation, and if I run the test case, you can see the add test and subtract test methods are disabled. Well, here disabling these two test methods means JUnit will skip the execution of these two test methods while executing the test methods in a test suite. Hi everyone, welcome back. In this lecture, let us quickly take a look into JUnit Lifecycle Annotations. JUnit provides annotations to define test execution lifecycle methods. Well, JUnit provides us special annotations that help control how our test cases runs. These annotations help set up and clean up resources for test. Well, these annotations help us set up things before a test case starts and clean up after a test case finishes. And here are the annotations: at before each annotation, at after each annotation, at before all annotation, at after all annotation. So these are the 4 JUnit lifecycle annotations. Let us quickly take a look into one by one. At before each annotation. Well, at before each annotation runs before every single test method in a test class. Think of it like getting everything ready before you start a task. For example, if you are testing a calculator, you might want to reset the calculator to 0 before each test so that tests don't interfere with other test cases. Next, after each annotation. Well, after each annotation runs right after each test method finishes. It's like cleaning up after you finish a task. If you opened a file during the test, you would close it here to make sure everything is tidy and ready for the next test. Next, add before all annotation. Well, add before all annotation runs once before all the test cases in a test class. It's different from add before each annotation because it only runs one time. This is useful when you have something that takes time to set up. For example, connecting to the database. So connecting to the database is kind of an expensive task, so you only want to do it once. Okay. Next, add after all annotation. Well, add after all annotation runs once after all the test cases have finished. It just like add before all, it only runs one time. So this is where you put all the cleanup tasks that should only happen once, like closing the database connection or writing a final log entry. Okay, so this is a quick introduction to these 4 JUnit lifecycle annotations. In upcoming lecture, we'll learn each these lifecycle annotation with examples. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into at before each annotation. Well, at before each annotation is a JUnit lifecycle annotation. At before each annotation marks a method that should be executed before each test method in a test class. Well, whenever you want to mark a method that should be executed before each test method in a test class, then you can go ahead and annotate that method with at before each annotation. This annotation is pretty useful for setting up the test environment, such as initializing the objects and setting initial conditions. Well, instead of writing the same repeated code in each and every test method, we can create a method and we can keep the common code in that method, and we can annotate that method with at before each annotation. Okay, so in this way we can reduce a duplicate code. And this at before each annotation annotated method ensures a clean state for every test method. Next, let us go ahead and let's understand at before each annotation with example. So let's go to our project in IntelliJ IDEA, and here go to the test package and go to the annotations package over here, and here right click, new, and then choose Java class. Let's give class name as before each demo test. Next, within this class, let's create a test methods. Well, here we have a calculator class. It has a methods add, subtract, multiply, and divide. Next, let us go ahead and let's write the JUnit test cases to unit test all these methods, and then we'll use at before each annotation to mark a method that should execute before all the test methods. Okay, so go to the before each demo test class over here, and here let's quickly create a JUnit test cases. Well, in previous lecture we have already written a JUnit test cases to test calculator class methods, so let's quickly copy it. Go to the disable calculator test class, and here just copy these 4 JUnit test cases. So instead of writing the same code, let's copy it so that we can save some time. And here let's remove this disabled annotation, and let's also remove the import. Perfect. Now we have add test JUnit test case. Within that we have written a logic to unit test this calculator add method. Next, here we have subtract test JUnit test. Within that we have written a logic to unit test subtract calculator method. Next, here we have multiple test JUnit test case. Within that we have written a logic to unit test multiply calculator method. Next, here we have divide test JUnit test case. Within that we have written logic to unit test divide method of this calculator class object. Okay, perfect. Next, if you closely observe this code over here, we have created the instance of calculator class each and every JUnit test case. Okay, and think like, why not we create a common method and we keep this common piece of code in a common method and we can call in a respective places. Okay, so let's do that. So here let's create a method void, and let's call it as setup. Okay, and within a setup method, let's create a calculator class instance. Perfect. Next, let us call this setup method in each and every JUnit test case. So instead of this calculator object here, just call calculator equal to and then setup. Next, this setup method should return the calculator class object. So here just change the return type of the method and let's add calculator, and here let's have return statement and then return calculator object. Okay, perfect. Next, if I run the JUnit test case, this should pass. Okay, similarly we can just remove the object of calculator class from each and every JUnit test case and we call this setup method. For example, let me call this here as well. Similarly, let's go to multiply test and just call setup method, and in a divide test also call the setup method. Okay, perfect. So this is how we can reduce the code. Okay, by keeping the common code in a separate method and calling that method in a respective places, we can avoid the duplicate code. Okay, next let us run the test class and look at here, all the test cases passed. It means we have successfully refactored the code. Next, let us think like instead of calling this method in each and every JUnit test case, why not the JUnit itself execute this method before each and every JUnit test case within this test class. So this is where the at before each annotation comes into picture. Next, let us go ahead and let's annotate this method with at before each annotation so that JUnit will execute this method before each and every JUnit test case. So in order to use at before each annotation, we should make this method return type as a void. So here just mark void and remove this. Okay, and remove the setup method call from here, and here let's declare the calculator instance here, private. Okay, and just create an instance here like this. That's it, and remove the setup method call from each and every test method. Now we also reduce some lines of code as well. Okay, next let us go and let's annotate this setup method with at before each annotation. Make sure that you choose at before each annotation from org JUnit Jupyter API package. Perfect. Next, let us go and let's run the test class. And notice here test passed. It means that at before each annotation annotated method executed before each and every test method in a test class. Next, in order to make sure that like this method is really executing before each test method, let's go ahead and let's put the system.out.print statements. So here let's have a sysout and just print setup method calling, something like that, and just copy this system.println statement and go to add test method and here just paste it, and let's call it as add test method calling, and go to subtract test, paste it, and here just add subtract test method calling, and then go to multiply test, paste it, and just change to multiply test method calling, and go to divide test, paste it, and here also change divide test method calling. Now we have added system.out.println statements to each and every JUnit test case so that we can make sure that this setup method is executing before each test method in a test class. Next, let us run this test class and just check the result, and here you can see setup method calling before each and every test method. You can see setup method calling, setup method calling, setup method calling, setup method calling. The setup method is called 4 times and there are 4 JUnit test cases. Alright, so whenever you want to mark a method that executes before each and every test method in a test class, then you can go ahead and annotate that method with at before each annotation. And this is basically useful whenever you have a common piece of code in each and every JUnit test case. So you can keep that common code in this at before each annotated method so that this common code will be executed before each and every test method, just like this. Okay, great. In next lecture, we'll take a look into at after each annotation. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have seen at before each annotation. So we use at before annotation to mark a method that should executed before each test method in a test class. Now in this lecture, we are going to see at after each annotation. Well, at after each annotation is one of the JUnit lifecycle annotation, and this annotation marks a method that should be executed after each test method. So this at after each annotation works in the opposite way to at before each annotation. This annotation tells JUnit to run a method right after each test method finishes. The purpose of this at after each annotation is to clean up after each test. Next, this is useful for cleaning up the test environment, such as resetting the variables or closing the connections. For example, let us say if the test method opens a file or a database connection, the at after each annotation is where we would close that file or a connection. This ensures that no leftover data or resources carry over to the next test. So this helps maintain a clean state between the test methods. Okay. Next, let us go ahead and let's understand at after each annotation with example. So let's head over to our project in IntelliJ IDEA, and here we have a before each demo test class. Let's copy it and paste in the annotations package, and let's give name as after each demo test, something like that. Click on OK. Next, in previous lecture we have used at before each annotation to mark a method that should be executed before each test method. Now let us see how to use at after each annotation to mark a method that should execute after each test method. So here let me create a method. So make sure that the method return type should be void, and let's give method name as tear down. So we typically give the method name that we annotate with at after each annotation should be tear down, and then let's annotate this method with at after each annotation. A should be capital, and make sure that you choose at after each annotation from org JUnit Jupyter API package. Within this method, we typically write a code to clean up the resources. In this example, we don't have the resources like file closing or database connection, but here we do have an object of the calculator class. So let us assign a null to this calculator class object so that the calculator class should be null before each and every test case. So this ensures that the calculator object state should be clear before each and every test. Okay, so just to make sure that this tear down method execute after each test method, we'll keep the system.out.println statement over here. So just copy this sysout and paste it over here, and just change this. Let's give tear down method calling. Okay, next let us go ahead and let's run the test class, and let us check the result. Test passed 4, and look at here the logs in the console. Setup method calling, divide test method calling, and after that tear down method calling. Next setup method calling, add test method calling, after that tear down method calling. Setup test case tear down, setup test case tear down. Okay, it means the tear down method we marked with at after each annotation is executing after each test method. Okay, so these statements clearly demonstrates that the setup method is calling before each and every test method in a test class, and this tear down method is calling after each and every test method in a test class. Well, whenever you want to mark a method that should execute after each test method in a test class, then you can go ahead and annotate that method with at after each annotation. And this at after each annotation is pretty useful whenever you want to close the database connections or close a file. Okay, so basically we write a logic within this method to clean up the resources so that each and every test method get a clean state. Okay, great. In next lecture we will see at before all annotation. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we'll discuss at before all annotation. Well, we use at before all annotation to mark a method that should be executed once before all test methods in a test class. Well, whenever you want to execute a method that should run once before all the test methods in a test class, then you can go ahead and annotate that method with at before all annotation. So notice here the difference between at before each and at before all annotations. At before each annotation, we used to mark a method that should execute before each test method in a test class, but this at before annotation we used to mark a method that should be executed once before all test methods in a test class. This is useful for setting up shared resources such as establishing database connection or starting a server. Well, establishing database connection is kind of an expensive task, and if we establish database connection in each and every test method, it consumes a lot of time. And we typically share the same database connection in each and every test method, right? So instead of establishing the database connection in each and every test method, we can create a method and we can mark that method with at before all annotation so that this method should execute once before all the test methods in a test class. Okay, and in case of starting the server, so before running the test methods, we typically start the server only once. Next, at before all annotated method must be static, as the method is going to share the resources. So make sure that whenever you annotate a method with at before all annotation, you must make that method as a static so that it can share the resources among all the test methods, and also it should call before creating the object. Next, it is ideal for expensive setups that don't need to be repeated. Alright, next let us go ahead and let's understand this at before all annotation with example. So let's go to IntelliJ IDEA and go to our project, and here go to annotations package, and here we have before each demo test. So let us copy this test class and in an annotation package just paste it, and let's give the name as before all demo test. Next click on OK. So within this before all demo test we have a setup method which is annotated with at before each annotation. So just comment out this. Now let us go and let's see how to use at before all annotation. And here let's create a static method, static void. Let's give method name as setup before class. So this static method should call before creating the instance of this test class, because this method is a static method. Okay, well, within this method we write a logic that should execute once before any test method in a test class. In this example we can simply create an instance of calculator class, but in real-time project we write a code that share the resources among any test method in a test class. For example, establishing the database connection or starting the server or initializing the variables that should execute before any test method in a test class. Okay, so whenever you want to share the resources among any test method in a test class, then that logic you can write within this method. So for our example we can simply create an instance of calculator class over here. So calculator, and notice here method is a static, we should declare instance variable as static and then calculator equal to new calculator. Perfect. Next let us annotate this method with at before all annotation from org JUnit Jupyter API package. So once we annotate method with at before all annotation, then JUnit will call this method once before any test method in a test class. Okay, so just to make sure that this method is executing once before test methods in a test class, we can keep a system.out.println statement over here. So here system.out.println and just pass the string setup before class method is calling. Next, let us go and let's run the test case, and notice here test passed 4, and notice here the statements in the result setup before class method is calling, and notice here this statement is printed only once. It means this method which is annotated with add before all annotation called only once before these test methods. Okay, next, even if we execute a single test method, this setup before class method should call once. If you can notice here test passed 1, and the setup before class method is calling printed only once. In next lecture we'll take a look into at after all annotation. Alright, great, I will see you in the next lecture. Hi everyone, welcome back. In this lecture we'll discuss at after all annotation. Well, in previous lecture we have discussed at before all annotation, which we can use to mark a method that runs once before any test method in a test class, right? The at after all annotation we use to mark a method that should be executed once after all test method in a test class. Well, whenever you want to mark a method that should be executed once after all test methods in a test class, then you can go ahead and annotate that method with at after all annotation. This is useful for cleaning up shared resources such as closing database connection or setting down a server. Well, whenever you want to close the database connection or shut down the server after executing all the test methods in a test class, then what you can do is you can create a method and annotate that method with at after all annotation. Next, at after all annotated method must be static, as we are going to clean up the shared resources. So make sure that you make method as a static. It ensures cleanup after all tests have run. For example, closing the database connection or setting down a server. Well, once we execute all the test methods in a test class, we should have to close the database connection or we have to shut down the server, right? So this at after all annotation ensures cleanup after all tests have run in a test class. Next, let us go and let's understand at after all annotation more with example. So let us head over to our project in IntelliJ IDEA, and here go to annotations package, and here we have before all demo test class. So just copy this class and go to annotations package, just paste it, and let's give a name as after all demo test. Well, in previous lecture we have discussed at after all annotation that runs before any test method in a test class. Next, let us see how to use at after all annotation. So here let's create a static method, static void. Let's give method name as tear down after class. Alright, and let's annotate this method with at after all annotation, and make sure that you choose at after all annotation from org JUnit Jupyter API package. Perfect. So within this method you can write a logic to clean up the shared resources. In this example we can release this calculator object by assigning a null value. For example, calculator equal to null. Okay, but in real-time project we typically write a logic like closing the database connection or setting down the server. Okay, so basically we write a logic to release the resources or close the connections. Next, in order to make sure that this method is calling once after any test method in a test class, we can put the system.out.println and we can test that. So here just put the system.out.println and just give the statement like tear down after class method is calling. Next, let us run the test class and let us see how this method works. So from here let's run the test class. Notice here test passed 4, and look at the statements in a result tear down after class method is calling. So this statement is printed only once. It means the method which we annotated with at after all annotation executed once after all the test method in a test class. Okay, and even if we run the single test method, this method should call only once after that test case. You can see tear down after class method is calling. Well, whenever you want to mark a method that should be executed once after all the test methods in the test class, then you can go ahead and annotate that method with assertAll annotation. And this assertAll annotation is useful for cleaning up the shared resources such as closing the database connection or setting down a server. And make sure that you mark this assertAll annotated method must be static. Okay, great. In next lecture, we will take a look into other JUnit annotations. Alright, great. I will see you in the next lecture.